and I think is probably going to be the resounding question of 2026 is, what is my AI agent even building with? And how do I make sure it's safe? So this isn't a new problem, right? We've been grappling with software supply chain risks for years. Open source dependencies have been a major attack surface, with 70 to 90% of commercial software being open source, and the average dependencies per open source project being 1,200. You know, every dependency is a trust decision that's being made by someone somewhere. And that chain of decisions compounds quickly when you're pulling in packages that themselves have a lot of dependencies. But there was always a human in the middle who was making those decisions, who had the context of what an organization cares about and what's risky. So I think there's two things that have really changed that are kind of compounding each other. First is that AI has removed the human from that dependency decision, right? So when an AI agent writes code, it doesn't have the context of your environment, what's allowed, what's not allowed, what's your risk profile, what licenses are you okay with coming into your environment. And it's trained on code that may reference a vulnerable component. It's going to recommend that. So then at the same time, we now have attackers who are targeting developers specifically, not just the packages, but the people and the tools. Security researchers that were analyzing the recent Trivy breach said that developer security tooling is now the highest leverage attack vector because CI/CD pipelines have vast permissions and they're kind of just assumed to be trusted. So on its own, either of these developments is manageable, but together they're really changing the shape of the problem entirely. And they're both happening right now at the same time. Which is really the setup for what happened this past week. And I have to say, guys, I really wish that attackers would stop breaching software supply chain, because then I could leave my talk track instead of having to update it like daily the past couple of weeks. But I think that, if we think about light LLM, that is one really interesting attack that we're seeing in how it's really expanding the blast radius and where attackers are focusing. So Light LLM, the open source library that acts as a universal API gateway for LLMs, it's how developers can call OpenAI, Anthropic, Gemini, and dozens of other providers. It was breached and it has close to 100 million downloads per month. And it really sits between applications and every LLM provider with direct access to API keys, environment variables, and cloud credentials. This position, this very privileged position, is what made it such a easy or ideal target, right? It was a great one to compromise because right now AI is not being governed the same way that open source packages are and other dependencies are. One researcher actually called it a software horror because all you had to do was type pip install light LLM and it exfiltrated SSH keys, cloud credentials, Kubernetes secrets, API keys, and crypto wallets from any machine that ran it. And I think what's interesting about this one is this is really proving out the anatomy of a modern software supply chain attack. They did not find a bug in Light LLM's code. It was nothing about what Light LLM wrote. Instead, they compromised Trivy. And then through that, they were able to get access to Light LLM and publish a malicious package. The attack was actually only discovered because of a bug in the malware, and it wasn't because of a security control or anything like that. It's just that there was actually something wrong with it, and it crashed a researcher's computer. So again, the blast radius of this really expands beyond those teams that specifically chose to run Light LLM because it is AI infrastructure that so many other AI tools are running on. So that was a very sophisticated attack, but there's other less sophisticated attacks that we're starting to see because of AI, primarily slop squatting and hallucinated packages. With this is really where, AIs they're very confident, and they're going to recommend things very confidently, even if they do not exist. So an AI can, recommend a package name that sounds just almost right, or it's logical. And attackers can go and register that very cheaply and just wait for the moment that an AI model hallucinates that name. It has a malicious payload in it, and then it's cascading through your environment. And then there's really a third dynamic worth naming, which I didn't have a fun, like, cool name to give it. It's just more dependencies, right? Like, AIs are using dependencies the same way that we are, but the volume and the speed at which they are coding means that there is no way that a manual review process can make sure that the dependencies that are being pulled in are safe. And this is where I had to update my talk track, which is to talk about the Axios attack that happened yesterday in the early morning. So this was not an AI-driven or AI-generated attack, but I think it's a really great example of the types of attacks we probably will start to see at an increasing velocity. If you were paying attention to the news last summer, it felt like there was an NPM attack every day. And I had to write a blog post on all of them. And it's not fun, right? And then the same thing happened this week, where last week there was the light LLM attack, and then there was the Axios attack. Here, this was just a simple maintainer getting breached, right? It was a simple maintainer thing got pushed to NPM, and then it was about 3 hours where that package was live. And it was one of the most popular packages on the internet. And that's why it became such an attack vector. And I think if we think about it, right, like how do maintainers get breached? It's a phishing email, like you click a link, right? Well, AI makes it a lot easier to create really good looking emails, phishing emails, right? So I think we're going to start seeing that a lot more. And again, AI writes code that assembles existing libraries. It's efficient and it's reflective of how modern software already works. But at the speed that AI is making decisions, each dependency is a trust decision that we need to make sure that we are controlling. And it has to be automated versus a human making those types of decisions. So I have a couple more stats, and then I'll get into some of the things that we're starting to see teams doing to actually combat these types of attacks. So again, with Light LLM, the packages were only live for about 3 hours. For a team that doesn't have automated controls in place, that window becomes very hectic, right? Someone notices something wrong, an alert fires, maybe someone posts something on social media, you see it, you have to go track it down. Are we using that version? It becomes an incident, not just a confident we were protected. So our research found that only 37% of organizations can automatically identify, block, and trace a compromised package within minutes. What I think is more interesting is that nearly half have to rely on manual efforts to quarantine and remediate. So when the next LLM happens, which it already did because it was the Axios attack, that means that there's a lot of teams scrambling, right? And only 17% of organizations actually have dedicated scanning for AI-related risks, which means that about 83% have no automation to track those AI-created risks of like hallucination, dependency confusion, slop squatting, all of that. I think one of the more interesting ones as well is that only 27% of organizations we talked to were confident that they could pass an unexpected audit, which if for those of you guys in this room, with the Cyber Resilience Act coming in 2027 for the EU, this is something that we all have to start thinking about if we sell products into the EU market, where there's a 24-hour reporting requirement for like early warning. So again, if for those teams that are in that 48% doing manual quarantine and investigation, this becomes a countdown. And I think it really kind of underlies why we're starting to hear this, like, yes, this is a developer experience challenge. Yes, this is a security challenge, but increasingly it's a business challenge as well. So this kind of is where I shift into my the title of the slide or the presentation, which is that the old model was about verify or trust, then verify. And we really need to shift to a posture of verify, ship fast, assume packages are safe. We start seeing is enforcing governance adding in before artifacts reach the code base, before they reach the developer, before the build pipeline, treating AI models with the same discipline as any other binary, and using a unified control plane so that security policies can govern everything. But I don't want to leave this as just a list of to-dos or a framework. So I thought it would be good to talk about a couple of the practices that we're actually talking to our customers about and we're increasingly seeing people asking for. So first is consolidating artifact management into a single pane of glass. Right now, many organizations are managing their artifacts in fragments, and this is often by design because a lot of these tools can only support a certain number of packages, or even if they are in a single tool, it's forcing you into these very like format specific repositories. But we always kind of say you can't govern what you can't see. So once you have it all in one place, a lot of these other things become an option. So the next would be enforcing policy at the point of ingestion. You know, historically, we've had it where, you know, if something's in your artifact repository and you catch it at some point in the future before deployment or at deployment, then that's good enough. But what we're increasingly seeing is that developers are being targeted for the secrets, for their access to CI/CD pipelines, et cetera. So increasingly, we're starting to talk to people about enforcing at that very first moment of consumption and then continuously throughout. An interesting way that we start talking about is actually with cooldown periods. This is something that specifically would have helped with both light LLM and the Axios attacks, because the community typically catches these within a matter of hours or days. So a cooldown period is really designed to give you protection against the unknowns, and it is intentionally time-based. It is a way to balance security and speed. And then it pairs with continuous policy enforcement, right? So using a tool, so for example, how we do it is we work with Open SSF Malicious Packages Project, and we ingest their threat and their intelligence there. So as soon as it is identified by the community and it's then in that feed, a malicious package policy will block all of the known bad, whereas the cooldown periods are really about the unknowns. The fifth thing is golden paths, and this one is fundamentally about human behavior, right? We increasingly see people coming to us and saying, we want to build artifact management and software supply chain security as part of our golden path initiative. Security controls that add friction get routed around. So it only works if it's something that can be done without disrupting the broader workflow. And it really does flip that dynamic because they're pre-built, pre-approved ways of getting things done. And then the kind of sixth one is just defining trusted sources for upstreams as well as using hardened images. So being able to say that you have a trusted upstream source can help with dependency confusion, which is a really specific type of attack. And then we also see a lot of times people are starting to talk about using hardened images. So pre-using things like ChainGuard, hardened images, or Docker hardened images to make sure that you're using a zero CVE, lightweight container that is kind of taking out any sort of potential risk. So those are just a couple of the examples that we're seeing. And that is really it for me. And I do want to say thank you guys for your time today, but this is a QR code where you can go and download the rest of the report. I only talked about a very small subset of what was found in there. There's a lot of data about software supply chain risks, AI, as well as kind of like legacy infrastructure and the impacts that it's having on the community. So I would love for you guys to take a look at it. Thank you.
Oh, someone asked for the QR code again. Sorry, I've taken over the screen share, so it is my fault, but we'll do it at the end of the questions. Yeah. It's okay. So you can type questions into here, or you can also ask it in the mic.
Can't promise I'll have the answer.
I will come and give you the mic.
Hi there. Very interesting to see that you're saying that was I think like 94% of commercial software is open source, and clearly, as you've shown, AI is a massive threat to the security of that open source. So, is there a sort of thought for, that there should be a fork of those open source packages where one is sort of like community reviewed and the other one is sort of performance enhanced, if you like?
I'm not sure I fully understood the question. So the question
One's
was,
with AI and the other one's without AI.
I see. Yeah, it's interesting because, one of the things I talk about is that even if you choose, I mean, first of all, IBM put out their cost of it data breach study fairly recently, and it talks a lot about AI, and it's a double-edged sword, right? So like, we can't not use it. Like, it is actually providing a lot of productivity gains, and also if you're using AI for incident response, it is reducing the cost of those incidents. But there's also not, yeah, I think there should be transparency. I do think that there should be transparency.
It's a question on the board. So not being on the latest version of a dependency could be an easy solution to this complex problem. Do you agree?
Yes. Yeah, we talk a lot about like version pinning is obviously a option. A lot of package managers will, try and be really helpful and bring in the latest version of that dependency. I think we just don't see it very often. Like, we do see a lot of teams pulling in the latest dependency, which is why those cooldown periods can help a lot. Is it just makes it so that for that short time period you're protected, and then you can start pulling in the latest dependency after that. But it is certainly an option.
Any other questions for Meghan? Going once, going twice?
Thank you.
Okay. All right. You can put the QR code up again for that. Oh, yeah. One more. There we go.
Sorry, I forgot to type it in time. I guess I had a question, for lack of a better phrase. I know, given kind of a different, changing geopolitical situations, and we're seeing kind of, the attack surfaces grow. For example, I think there's groups like Kadarna and other that are kind of exploiting these sort of attacks. Do you find, because there's this kind of sort of like geopolitical, I guess, environment right now, that there are more companies than would normally be interested in this, or even, let's say, organizations that are starting to look into this when they would normally not?
I think it almost, see, you're pulling on my past life in cybersecurity here, because I come from the threat intelligence space originally. I think I mean, in only my opinion, I think we're probably seeing more attacks happening because of the geopolitical space right now, and because of those attacks, like it is top of mind for a lot of people that we're talking to. Like, increasingly, this is the reason that people are trying to figure out new solutions, is because of the software supply chain security attacks that we're seeing. I hope that answers your question. Okay. Here's the QR code for those who needed it.
All right.
Okay.
Okay. All right. Thank you very much then. Round of applause, please. And Ole, please come on. All right. Oh, yeah.
Sorry. Hello? Yeah. This is a plushie. I have 6 of these with me to give away. I had 7. One went to Cheryl. So if you save your questions, everyone who asks a question will get a plushie, or the first 6 questions. Let me see. Gonna share. Yay. Okay, great. Hi, everyone. I'm Ole Lensmar, CTO I was going to say wrong, Testkube, like I did last time. I was here giving a similar talk last summer, I think. Somewhat updated slides, more AI this time. Testkube is a test orchestration platform for Kubernetes, and I'm going to talk more about it later on. I'm going to start talking more about just testing. In general, my background is in testing. I've been in testing for 20, 25 years. If you're familiar with Swagger, that's something I was very involved in and worked at Smart Bear and a bunch of other places. So don't want to talk about myself. So let's see here. Okay. Cloud native and AI are changing the way we build software. I don't think that's a big surprise. Microservices, containers, Kubernetes, been up and coming. Dynamic and ephemeral infrastructure and infrastructure as code, not new anymore. We're moving more to asynchronous pipelines and GitOps, progressive delivery. A lot of talks about that at KubeCon last week, both in our booth with our users, but also just in the sessions. Obviously, there's ArgoCon, etc. AI is being used more and more for testing, for code generation, for test generation, and for more and more also for generating configurations and infrastructure. And we're seeing more and more people actually using agents and letting agents implement entire features and also create tests. And all of this, of course, also impacts how we test all these things, or how testers in QA have to build their pipelines. And if you look at kind of this, I'm not sure what this is called. I guess it's a infinity loop. It's a some sort of life cycle, CI/CD. You can say testing is something that's involved, or test-related activities are happening during the planning phase, during the coding phase, obviously, during the build phase, especially during the testing phase. But we're also seeing that testing is part of release, part of deployments, post-deployments, in operations or pre-production, and here and behold, a lot of people do testing in production. So testing is really something that happens all across the life cycle. And this is, shift left has been kind of pushing testing to the left, and that's not new. Shift left's been around for a while. Shift right is reasonably new, which is more about trying to collect quality metrics from production or pre-production environments. So doing testing later, just to be able to push more code through the pipelines. And all of this is kind of just proliferated, moving out testing from maybe the testing phase, which most people think about when we talk about testing, to be across the entire pipeline. And this, of course, in the context of microservices and containers and Kubernetes, multiplies, right? You have multiple of these things going on. Each team, each component, each microservice is at different phase in this pipeline. It's being deployed into different environments. There's a bunch of testing tools being used, different versions. You know, Selenium was replaced by Cypress, which is now being replaced by Playwright. Same thing has been happening in other areas, but all those tools are still around. And we're triggering tests in a bunch of different ways. So we're not anymore just running tests from CI/CD, but we're actually running them in our clusters, maybe based on deployments from Argo or Flux, or we're scheduling our tests to run on a schedule, like every 4 hours for our end-to-end tests. Testing is just kind of everywhere. And of course, AI adds to this. So if we look at this continuous delivery concept where you have continuous integration and continuous deployment, there actually needs to be something called continuous testing, which really means testing happens all the time at every step of this SDLC. It's automated and it's event-driven most of the time. I'm not saying you shouldn't do exploratory testing, but a lot of testing is automated. Testing often leads to quality gates for release confidence. That sounds somewhat markety. I'm going to talk more about that a little bit later. And then test observability is super important. And maybe that question that you guys answered about what's really hard is about troubleshooting failed tests often comes down to observability. How do we know how can we observe our tests and the system under test so we can reliably and quickly troubleshoot why they failed? So a couple of challenges, though, when kind of trying to get all of this into place. One is just result consistency. It works for me, right? If I'm running my tests locally on my machine, I want to make sure that those tests run the same way in pre-prod, triggered by Argo, for example. And that's not always the case. And this could be just because you have different environments, you're using different versions of Kubernetes, you're doing different distributions of Kubernetes, you're using different versions of your testing tools. You might be using different pipelines or CI/CD tools, right? The test might work in GitHub Actions or in Jenkins, but it might fail under Argo just because they're using different runtimes. So these are all kind of reasons why consistency can be a challenge. The other is around observability. So when you test in a distributed architecture, the logs and the reports and the metrics and the artifacts that your tests produce are going to be all spread out across your infrastructure. You might have 10, 15 microservices being tested. You might want to know in an integration test? How do you capture all the logs from all of those components into one place so you can do an analysis of why a test failed? Finding the stack trace, where did things go wrong? Trace is obviously super helpful here. How do you maybe then associate? Also, you might want to correlate to other events. Maybe a test started failing because you upgraded I don't know, Prometheus to a new version, or you might have done some system network policy configuration that doesn't have anything to do with the application under test, but that change results in your tests starting to fail. How do you get that kind of data into the data that you use when you're troubleshooting your tests, your failed tests? And then how do you correlate all these things across each other? It's a challenge when you have a very distributed architecture, obviously. Quality gates and release confidence boils down to what makes up a release. So if we have all these components that we're releasing continuously, how do we know when we actually have a new version and that we feel confident, okay, now we can release these things together if they're being built separately, tested separately? And how do we aggregate quality signals? And a lot of tools like Cargo and Captain and Spinnaker have concepts of quality gates where you kind of promote releases, where you try to aggregate quality metrics from different tools and gate releases through different deployments. And that can be a challenge. And then how do you tie in non-functional testing? So often when we think of testing, we're thinking of end-to-end functional testing. And does it work? Does it do what I'm expected to? But a testing can be so much more. It can be performance testing, security testing, compliance testings, maybe even kind of supply chain testing that you touched on. Something that was really big at KubeCon was infrastructure testing. So we see a lot of people dynamically provisioning infrastructure as part of their pipelines. And how do you validate that infrastructure before you even start deploying your applications on it? How do you make sure it has let me see, I think I have some bullets here. How do you make sure, how do you make sure it has the CPUs or GPUs it needs? We have a customer of ours, CoreWeave, who provides infrastructure for LLM or AI workloads. They dynamically provision clusters that have to have a certain type of GPUs, certain amount of memory, certain volumes, certain components installed, and they need to validate that before they hand over that infrastructure to the end user. You might want to validate network access, RBAC, et cetera, et cetera. And especially in platform engineering terms where you're continuously provisioning, or maybe you're provisioning ephemerally as part of your pipelines. You're standing up a namespace or a cluster before you install the application to run your tests. You want to make sure that you have a baseline. So this was actually a very common discussion point at KubeCon. So people are thinking about this. And then platform engineering, who's kind of platform teams trying to provide guardrails and kind of templates maybe for service and application development. Testing should be part of that. And as we know, the actual application teams like to be autonomous and don't want to be told what to do. So they need to have some freedom on what testing tools to use, what pipeline tools to use. Maybe someone wants to use Flux, someone wants to use Argo. I don't know if that's a pretty big, broad degree of freedom, but especially around testing tooling or how they want to analyze those results, where do they want to push that data to kind of collaborate on it. And then generative AI, of course. How do you maintain delivery and velocity? Delivery velocity and confidence when you have AI generating more code, more tests, and you also have AI agents themselves that need to be tested. I don't know if you're familiar with evals, basically evaluating an AI and LLM, that it's accurate, that it's relevant, that it isn't toxic, that it's not biased. All these kind of aspects of AI or agents can be tested, and that can be automated, and it needs to be done, especially if say you're providing a chatbot as a part of a customer support experience. You want to make sure that that chatbot doesn't do things or answer in a way that you don't want it to. And in this case, the testing pipeline often becomes a bottleneck, and that was the other answer we had in the beginning. And we also heard this at KubeCon, people saying to us that we're generating so much more pull requests, we need to run so many more tests, but our tests are used to take 10 minutes, which was okay. Now they're taking 30 minutes, and that's not okay. And how can you help us either decide what tests to run, or can we make them go faster? And there's a bunch of strategies around that, and it obviously depends on what's important. So how do you kind of implement this a continuous testing approach? And what we see today, most people use their CI/CD platform as a foundation. They're in GitHub Actions, or they're in Jenkins or GitLab or whatever, and they kind of create a lot of scripts and workflows and YAML to kind of pipe a lot of these things together. The problem is with CI/CD specifically is that they're very pipeline centric, right? They don't give you a test centric view of what's happening. If you want to see like I want to see all my tests. What tests are we actually running across all our pipelines? What are the results for all of those tests? So when you want to go dig deeper, what you usually end up doing is that you start integrating other tools to help you solve that problem. So maybe you're pulling in a reporting tool, you push data to Grafana or to Datadog or some other tool, and start kind of cobbling together your own solution to solve for the kind of second degree problems that arise as you go deeper. And that can be great because they're usually really good at those things, but it does also add a lot more maintenance, dependencies, security. You'd have to federate who has access to what, and how do we make sure that the right people can see the right results, et cetera, et cetera. I am leading the witness. There could be a dedicated solution for this kind of problem or domain. So a tool that's really built to solve many of the problems that I outlined earlier. The cons with a tool like this is that they'll be more broad or wide than deep. A general solution will never be as good as Grafana for building very specific reports for a specific type of test. And of course, you'll be locked into that tool as well, or to some extent at least. Another question is, who owns this continuous testing in an organization? Whose problem is it? And it's often something that kind of falls between chairs. Do you say that in English? No? Okay, you say it in Swedish, but not in English, but in Swedish. So it's something that nobody really takes responsibility for. In a perfect world, you would say that testing strategies and standards is owned by QA, or Technology Center of Excellence. Testing is done by Dev and QA, of course, but platform engineering is usually the people that own the CI/CD pipelines, the testing infrastructure. The test observability is usually owned by DevOps and platform engineering because they're the one managing all the kind of stuff where the tests are running, and they're also responsible for collecting all that data. And then doing non-functional testing is also something that's usually on the DevOps teams or a QA within a DevOps team. So the people who are responsible for performance, for security, etc., could be dedicated QAs in the DevOps organization, but it's often DevOps themselves. I don't know. Do you agree? Does anyone kind of have an experience or does testing in non-functional testing? Load testing? Who does that at the places where you work? No one. Okay. We have a performance issue. Okay. I'm sure someone does it. Okay. So hopefully the QA team's on top of that. Okay. Obviously, this leads to Testkube, which is kind of a platform that we've built to solve at least some of these problems, not all of them. I don't know how we are on time. I'm going to talk through a bunch of slides. I can do a little bit of a demo as well. But what is Testkube? So Testkube is to automated tests what Kubernetes is to Docker containers. So let that sink in. Kubernetes is great. You can have Docker containers on their own on your desktop, but if you need to run Docker containers at scale, lots of them securely, consistently, etc., use Kubernetes. You can run your automated tests locally. That's fine. But if you need to run a lot of automated tests at scale, consistently, blah, 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 securely, you can use Testkube. And it kind of provides you a lot of... I'm sorry, BDD and TDD with... What's the difference? Okay, so BDD and TDD are more approaches to how to perform testing. So test-driven development is kind of, and behavioral-driven development. You can, let me get back to that when I explain what Testkube is, but maybe here, actually, I'll say what it is not, because that might answer your question. So, yeah. So Testkube is not a testing tool. Testkube is a platform that takes your existing BDD tests, so if you're using Cucumber or whatever, but also your existing performance tests, your existing end-to-end tests, your API tests, whatever kind of tests you might have. It could be infrastructure tests, which is, as I said, very common. It takes those tests, runs them in Kubernetes at scale, and provides all the other stuff that you see on the sides, consistently, scalability, observability, etc. So it doesn't replace BDD, and it doesn't replace TDD at all, because TDD is more of a methodology, which you can definitely use together with Testkube. So we have several customers using BDD, like Cucumber, together and running Cucumber tests with Testkube. But it's not a testing tool. So when people are concerned when they talk to us, like, okay, do I have to rewrite all my tests? No, you take your tests, whatever tests you have, we'll run them for you, and it'll be much better than before. We like to think. We also don't do, just a sec, we also don't do testing environments. A very common question. Do you help us provision the test environment itself? No, we don't. That's something you can use. Argo can provision ephemeral namespaces. You can use Octeto. You can use, I don't know, Guard.io. There's a bunch of vendors out there who are focused on provisioning a testing environment, installing the application under test, loading it with test data, and then you can run your tests. We integrate with those tools, but we don't do that ourselves. So we're all about running your tests, and once again, whatever tests they might be. Yes, your question.
How to help them to scale up the
Use this
product?
for the recording.
So the question was, if a software wants to scale up their product to...
For example, 40 million to 100 million for the data point, is such as how the Testkube can be held to scale up the infrastructure.
So Testkube can help you test that you have scaled up your infrastructure. Testkube does not do the scaling. Testkube itself will not scale your infrastructure.
Yeah, but we need to have testing the infrastructure should be work for the 1 million data point before that, and then to deploy before.
Yeah, so Testkube you could create a performance test to validate that your infrastructure can handle the load that you're looking to create, and then Testkube can run that test for you. And you would probably do it in a way that you can configure that test to how much load it should generate, and then Testkube can run the tests for you with different load and give you the results, and it can help you then make sure that you've allocated the right capacity for your system. But the actual allocation of the capacity is still up to you. We can help you validate that you've...
Yeah, I know you can't help me to validate it, but it's just the how to you set up with the Kubernetes with the horizontal auto scaling, the with testing. Yeah, it's just that one. Okay.
Okay, so let me get back to your question. So I'll go through some slides and we'll go back. I'll get back to the end. So just to thank you. Okay, so why would you use Testkube? Just to kind of... One is decoupling testing from CI/CD. So today testing is, or often is very tightly coupled to CI/CD pipeline. You have your GitHub Actions, there's some steps in there that runs your end-to-end test, or you have your Jenkins pipeline or whatever. And often people realize we actually want to use these tests in other ways. We want to run them, maybe they're transitioning from Jenkins to Argo, right? We want to be able to run these tests from Argo. We want to run them on a schedule. We want to run them when something changes in our infrastructure. We want to trigger them when we update our, I don't know, deployment using Argo once again. So we wanted, Testkube allows you to kind of decouple. You can still trigger your tests from CI/CD, but you can also trigger them from a bunch of different points. It's testing tool agnostic. I think I've said that a lot of times now. Any kind of test you might want to run. It centralizes test observability. Testkube automatically collects all the logs and artifacts and metrics and everything into a control plane so you can easily troubleshoot. I'll show you a little bit what that looks like. It's cloud native, yay. So ultimately it runs in Kubernetes. So it runs your tests in Kubernetes. So if you're not using Kubernetes, Testkube is not for you, or it's probably not for you. One of the reasons Testkube is good at scaling tests is because it leverages auto-scaling and all these features in Kubernetes for test execution. So if you need to run a massive load test, maybe going back to the scenario with K6, and you want to scale out across 100 pods to generate, I don't know how many million virtual users, Testkube can provide allow you to do that. Obviously, you'll need to have the resources in your cluster to run that kind of test, but Testkube makes that fairly easy to do. It uses CRDs, so it's kind of easy to use with GitOps, and has a bunch of it emits Kubernetes events, and it's very close to Kubernetes in itself. And then there's a bunch of AI features. Of course, I have to mention AI, but it took me quite many slides actually. So, but I'll get back to that. So, and AI is actually really is pretty good. It's actually really good for many downstream activities related to testing. So often when people think AI testing, they think, okay, AI to generate tests. That's maybe interesting, but it's also AI is super interesting in many other scenarios, and I'll get back to that. The architecture, if you're familiar with the term, is kind of how we describe Testkube at a very high level, is that it has 4 pillars, a test workflow catalog, basically the catalog of all the tests that you're running, regardless of how they run, what kind of tests they are, when they run, etc. An execution engine, which leverages Kubernetes for running tests. A test observability layer where it collects all the results, and then it has an analytics portal where you can do reporting and the kind of stuff that QA managers like to do. And it's AI and cloud native. I think here might be more interesting to talk about more from a technology point of view. Architecturally, there's 2 components to it. There's a control plane and there's an agent. The agent is installed in your cluster and is what actually runs your tests. The agent is open source. You can get this on GitHub. We have plenty of companies using it. The agent is the actual execution engine of Testkube. So all the infrastructure testing and load testing, all the stuff that we talked about, you can do with the open source component of Testkube. And the more agents, you deploy an agent wherever you want to run your tests. So many of our customers, they have lots of clusters or they have lots of namespaces where they might want to run their tests. They deploy agents in each of those to run the tests for them. At some point in time, the agent you interact with through a CLI or through the REST API. Not super easy, but it works. If you're looking for a more visual interaction with Testkube, that's where you look at the control plane, which is the commercial component, which is the thing on top here, which adds a bunch of extra features, a nice dashboard, which I'll show you, but also reporting and an MCP server and a bunch of kind of enterprise-ready functionality for managing lots of agents in your infrastructure. And this, of course, then integrates with your SSO providers, with your repositories, with whatever you might have. All storage is done in a database, of course, just to kind of show if you're just running the open source agent, it'll use its own database on its own. This is all on-prem. It's an on-prem product. It's running in your infrastructure. It can run air-gapped. Many of our customers are.
Could you tell a bit more about the load testing? Because typically, I don't want to derail the presentation, of course, but typically I think load testing may be a bit on the side, right? It's not part of like unit testing, of course, but also it's not the user journey, right? It's stressing the system.
Yeah.
So how do you approach it? And
I'll do a short demo, so I'll show you.
course.
Is that okay?
Yeah.
Okay.
Of course.
Cool.
Thank you.
Okay. I think I'm done with this slide. Any questions here? No. Okay. Testkube also has AI features and has what we call AI agents, not surprisingly. So AI agents in Testkube are great for a bunch of things. Troubleshooting was kind of the top thing on that list. AI is great at that. If we collect all the data for you related to a failed test, we give it to an LLM, say, analyze what went wrong. AI is really, really good at kind of going through all those results, the metrics, the logs, whatever, and at least giving you an assessment of what went wrong. Obviously, it's still up to you to agree or not. It's also really good at just analyzing resource usage of your tests, kind of looking at, okay, since we collect that data also in Testkube, kind of how many CPU usage, memory usage, it can look at, okay, these tests use more resources than these. These are the ones that maybe cost you more than others. It can also help you maybe then identify these tests always pass, but they use more resources than anyone else. Maybe you should scale down how often you run these tests. Remediation, very nice use case, somewhat advanced, is about actually looking at a failed test, looking at the source code, trying to figure out why the test failed, and suggesting a fix to that failure. obviously you need a human in the loop. I'm not advocating for like letting AI just fix its own problems and deploying to production. There always has to be someone in the middle, but it can, a lot of kind of the grunt work of digging through logs and figuring out what went wrong is something that's AI is really good at. And the agents in Testkube, you could trigger them manually. You can run them on a schedule. Let's say maybe every 4 hours, you want to say, okay, look at all the failed tests. Tell me which ones are flaky, or tell me which ones use the most resources, which cost the most. Put a list on Slack so our ops team can look at that. It doesn't have to be super advanced. It can be very tactical, but makes it super helpful. Of course, there's an MCP server. So if you want to build these kind of agents in external tools, if you're using Claude, Cursor, whatever, like you mentioned, but also N8N or other agentic orchestration frameworks, you can do the same kind of features from an external tool. It doesn't have to be done through Testkube itself. The MCP server exposes all the data and tools that you would need. Specifically for like in the DevOps and platform engineering context, what could be some interesting use cases for an AI agent? So one is infrastructure triage. So every time a test fails, you can have an agent that looks at tries to figure out, was this an infrastructure failure or was it an actual test failure? It can look at all once again and say, these are out of memory errors. Is it a timeout error? Is it a network error? And then it could either just categorize your failures. It could post to the corresponding teams if you have Slack channels or whatever. So that in itself is usually quite some work for QA teams just to figure out, why did the test fail? Was it because there was an actual bug in the system, or was it because something was flaky in our infrastructure? This is something that AI can help a lot with. Correlating incidents. Let's say a lot of tests start failing at the same time. AI could look at all those logs and say, hey, we're all getting network errors related to, I don't know, some subnet in our network. Doing that manually is a lot of work. It's super easy for AI to set up, to kind of find those correlations across multiple test and failure incidents. I've mentioned cost analysis already, but I think what I'm trying to say here is that there are a lot of very tactical use cases for AI. It doesn't have to be rewrite my application to support the new version of whatever. It can be something very tactical that just helps with day-to-day work for an ops team or a QA team, for an engineering team. And Testkube is really well positioned because we have all that data. We know all the tests you're running. We know all the results from all the tests that you're running. We gather all this metric and we make them available through MCP. So you can use it externally, but also inside the tool itself. And I've said that. And of course, with MCP server, I don't know how, getting a little bit too deep in AI, I feel now. But anyway, with AI, you can also pull in external data through MCP servers, right? You could pull in add the Kubernetes MCP server. So an agent could actually look at the event logs from Kubernetes or look at read quotas, I don't know, pods, whatever, to further help it do triaging. It could be pulling data from Prometheus, Grafana. It could be looking at stuff from GitHub, Slack. These agents, whatever you give them access to, kind of broaden, of course, the possibilities of what they can do. You have to be careful what tools you give them access to, so they don't do things you don't want them to. But the tooling has come pretty far in that regard. Okay, how are we on time? Okay, I'll do a really, really short demo. And because there was also a question about, okay, so this is the main dashboard of Testkube. So this is running against a control plane, and I'm actually going to switch to just to kind of cater to your question over there. These are different, what we call workflows for different types of tests. So when it comes to load tests, we have, for example, here K6 load tests. We can just look at a specific K6 load test. I'm just going to start by proving the point. This is a Kubernetes CRD. So if you thought you were going to get away from YAML, you're wrong. Ultimately, these Testkube uses CRDs to define how to run your tests. This is how you define a K6 test. I can run this K6 test. Does everyone know what K6 is? Very common load testing tool. I can just trigger this K6 test here, and what's actually going to happen is that this is going to start running inside our Kubernetes infrastructure, and Testkube will now capture the logs. It'll clone the repository containing the test. It's going to pull down the K6 image from Grafana. or from Docker Hub, I guess, and then run that K6 test eventually. If I want, we can let it finish. It's going to take a little while. If I want to trigger this test from, let's say, GitLab or GitHub Actions, we provide you kind of with the configuration you would put into those pipelines to trigger that test. If you're using Argo CD, here's a post-sync hook that you could put into your Argo CD application that would trigger the execution of this specific K6 test. I could also set up what we call a test trigger, which is Testkube's capability to listen to events in your Kubernetes infrastructure. So let's say I want to run a specific test whenever I update a config map, because that config map holds the configuration for my application. So when I change that, I want to make sure that the application continues working. I can set up a trigger here to say, whenever that config map changes, run this end-to-end test, which is a really powerful way because that change cannot be bypassed. That test will always kick in, regardless if it's a kubectl apply or if it's through Argo or through other mechanism. It can also be annoying, of course, if that test takes a lot of time. Can go back to that test that we ran. Can look at the results here. This was the output from K6. We can look at the resource usage. So this was kind of the CPU memory used by that K6 test, et cetera, et cetera. And this is kind of the pattern for all of the tests that we have here. These are a bunch of different testing tools, but you can obviously group and annotate the tests in any way you want to, based on team, based on component, based on whatever. I don't know if I answered your question about load testing. Okay, I'll go on. Thanks. Obviously AI, I did want to go back to, let's see, where was I when I started? Here. Yes, okay, great. So here I had actually defined those agents that I talked about. Sorry, I have to move stuff around here. So we have an infrastructure triaging agent. This agent this is the prompt that it uses. I don't know if that's probably hard to read, but if you're familiar with agent prompts or skills, it's going to look very familiar. And this agent will kick in every time. I've configured it to kick in every time a test fails. So we can go in and look at, and then what it does is that it categorizes the test and tags the execution itself. So I'm going to somewhat curious if it's actually done that, because I set it to run earlier today. So here we have a test that failed. Did it do what I wanted it to? Almost. So what we're going to do here, I'm going to look at this failed. This was a failed Selenium test. I'm going to use AI Analyze, and I'm going to use a troubleshooting agent to kind of troubleshoot the kind of the thing that we talked about in the question, what you spend time on. So this agent here is now going to troubleshoot. Oh no. Oh well. You'll get so actually here it tells us, why did this test fail? So it gives us analysis, the context, most likely root cause. It gives us a bunch of things, and it'll probably give us a next step to pinpoint exactly where it hangs. So this super helpful kind of just initial root cause analysis of why this test failed. And this could be automated then for any kind of, to be kick in whenever a test fails. So you could also set it up to say, hey, create a Jira issue for this test failure, or post it on a Slack, post your findings on a Slack channel, for example, to show you, to help get people started with troubleshooting that specific test. I wondered if I had some other interesting examples. Let's see, AI analyze. We can do that triaging agent that I showed you before. So once again, this agent is now, if you remember, I showed you that long prompt. That prompt is now going through GP2.5.2. It's using the tools available to it, and it's kind of showing me an analysis of why this test failed once again. And once again, this could be, sorry, it's a little bit crowded here. And it's actually tagged the, okay, it tagged the execution of the test as a test failure. So this specific failure was not an infrastructure failure. It was not an out-of-memory error or anything like that. But this was actually an expected test failure, which is good. Nothing wrong in my infrastructure to show. What else can I show in the product? I don't know, how are we on time? A little bit. Okay, I'll jump back to the, if you want to see more on Testkube, happy to show you more after the talk. Okay, a little bit more what I talk about is testing in AI and kind of where are things heading, because AI can do a lot of stuff when it comes to testing. It can help, if we just back up a little bit, forget about Testkube. Analyzing requirements, AI is really good at that, as you probably know. And creating test plans is something that AI can do really well. It can help you create tests, and I'm sure, as you're probably thinking, it can generate code, so it can probably generate tests. And if it has good requirements for how things are supposed to work, it'll be able to create reasonably good tests from that. It can help you decide what tests to run. It can run tests using natural language. There's a bunch of vendors out there doing this for you. It can do deep result analysis, remediation, et cetera, et cetera. All this adds up to more pressure on your testing and delivery pipelines because things are going faster and more stuff is being built. So if you remember this picture, AI testing agents in the future could be everywhere. They could be helping you planning, creating your requirements. They could be helping writing your tests as code. They could be helping running tests, unit tests. Could definitely be helping running end-to-end tests or integration tests across the pipeline. Just where we had testing activities in the original one, we could now have AI testing agents doing many of those things for you. And you need some kind of AI orchestration platform to do that. And if that's Testkube or not, we'll see. Question is, what do testers do in that world? I mean, I'm guessing developers ask themselves, what will I do when AI generates all the code? Same question will be for QA. What do I do if AI generates all my tests? And as you probably know, there's still a lot of work to be done on giving the agents the right context and the skills and the prompts, which is a science in itself. It's taken us a lot of time to get these prompts right in Testkube itself. Defining what agents to have where, like in this picture here, what agents do we have where, what prompts do they use, what context will they have, and how do they interact with other agents, maybe agents that generate code. You have one agent writing the code, which hands off to an agent that then generates the test. The orchestration of those tests still requires a lot of expertise, obviously. And then finally, manual testing and exploratory testing is definitely something you still need to do. So I don't think AI will ever replace testing as a skill, just as much as it might not replace code. And the practice of exploratory testing, I don't know if you have exploratory testers at your company, it's an immense value. And some people just have that talent of finding bugs, as you probably know. Some people can go into a website and immediately find something that doesn't work. And AI is not great at that, but exploratory testers are great at that. For platform engineering, it's still going to be around providing and managing testing infrastructure, but that's not going away. If AI writes tests and AI writes code, those tests still need to run, and there still needs to be infrastructure to run them at scale. So that is not something that AI is going to solve. So the provisioning of testing environments, the actual test execution is still something that's going to be there. And then, of course, integrating those tests and the agents into the pipelines is also something that I think platform engineering and ops is going to continue to have to do, regardless of if AI is going to drive the generation of the artifacts leading to that. And that was all. And did I? Okay, reasonably well. Thanks.
Hey, we've got a handful of questions on the poll, so I'm going to take over.
Okay.
And, put these up.
Okay, and if you want a plushie, you're going to have to say who you are.
All right, so first one, where does the AI reasoning run, inside the cluster or outside? What are the data privacy implications for teams with sensitive test data?
Great question. So we don't provide our own inference or LLMs, so you either connect it to your OpenAI or Anthropic account, or you host your own LLMs. And several of our customers have their own LLMs, so which they host internally. So nothing goes outside, and you can just configure Testkube to use those LLMs or those endpoints. So it's, as I mentioned, we have air-gapped customers, and they're also keen on using AI, so they've kind of figured that out. It's all configured. So who asked that question?
Okay.
Okay. There you go. Oh, sorry about that.
Okay, with regards to security testing, such as Kubebench to test clusters against COS benchmarks, what benefit does Testkube provide over just running Kubebench as a Kubernetes job?
So it'll be that visibility of all the tests that you've run. So if you run all your Kubebench tests over time, let's say you run them on the schedule. So Testkube will allow you to schedule those tests and say you want to run them once every morning at 2 o'clock. It'll obviously do that scheduling for you. It'll run the test for you. It'll aggregate the results. It'll provide you, I didn't show the insights analytics module. So you could do reporting on that over time. You could add an AI agent to analyze the results of Kubebench afterwards, and then that agent could post the summary on Notion, for example, or put it, I don't know, whatever you might want to do for it. But you'd be wrapping in it into something more sustainable and easier to manage than just a one-off execution. Who asked that question?
Okay.
Okay, I'm gonna go get some plushies.
You said this one.
This is not only plushies.
Okay.
Okay, who had that one?
This is a great plushie game.
Oh, sorry. I'm sorry.
Are you okay?
Yeah.
Okay. Do you have production examples of the AI agent catching a real regression that a pipeline would have marked as flaky and ignored?
If I have a production, I have a contrived example from our internal environment. Well, I guess, which is a production environment, since we use Testkube to test Testkube. It's come to me afterwards and I'll show you in our environment if I can find it. But great question. But flakiness is a great example for AI also, just to kind of look at a failure. Is this a flaky failure? AI could automatically rerun the test for you if it thinks it's flaky. Or if it's not flaky, it'll just let it go because it has access to all the previous results. It can kind of try to determine if it's flaky or not. And flakiness is a very well-documented concept. So AI agents are the AIs are well trained on that. So they're reasonably good at making that judgment call. Does anyone want a plushie for that question? You only get one. Okay.
Is it you have a question or you have a... Okay, let me come to you and then I'll keep going with the ones on the board.
Yeah, you can get one. Sure.
Thank you.
Okay, I'm going to get better at my growing. There you go. Oh, they don't fly well.
Hi,
Hey.
I'm an air-gapped customer. My question is, between security and testing my code, I don't want to be overloaded by code. There's a time and cost resource to testing all this. Can I prioritize, or is there a way your tool would suggest which tests are better to run or which ones are the slowest? I can't run all the tests all the time. This seems to be the way we are going through. Code velocity is increasing, but I don't have infinite time for doing infinite tests.
That's a great question. And that came up at KubeCon several times where, to your point, it takes too long time to run all my tests. Can you help me decide what tests to run for a specific code change? The short answer is no. I'll be honest. Once again, I'm going to pull the AI card. So this is the more, so if you can give AI a dependency map or some kind of understanding of this test maps to these components or code bases or whatever, an agent could say, okay, this pull request touches these files or these things, and know from there that this correlates, these are the tests I should be running for that. So the ultimate world would be if we could monitor your system while tests are running and kind of record like a coverage tool, but at the architecture scale and not at the code scale, and say, okay, when you run this test, what's actually touched? And you could use OpenTelemetry to do that to some extent. You could probably use eBPF to do to some extent to kind of figure out. We're not there yet. So it's something we're definitely going to want to do. Using smart like metadata on the tests that you have, an AI agent could probably go pretty far, but it does require you to spend some time on providing that metadata, which might be worth it, to your point, because it could make your pipeline speed up. You mean tests to monitor tests? Okay, yeah. So I don't have unfortunately, I don't have a solution for you apart from saying that AI should be able to do that. I'm happy to work with you on kind of trying to figure that out because you're not the only one who wants to. And
Okay.
you are worth a plushie as well, but are we short on time or what?
Yeah, we can
Okay.
take another couple of minutes. Got to get through your
It's too
plushies.
far to throw.
No, you can do it. Come on.
Okay. Oops, I cannot. They don't fly well.
Let me
Okay, sorry.
take one here.
Okay.
You need more aerodynamic plushies. Can we not use AI agent skills that were shown earlier and hook them in our CI/CD instead?
Sure. So, like I said, you could Testkube has an MCP server that exposes the exact same tools that the agents use inside Testkube. So you could use a skill externally or that has access to the Testkube MCP server to do exactly what you do inside the tool. This is up to preference. Some of our customers say we want to build externally in CI/CD, just like you're asking. Others are saying we'd like everything to be contained in Testkube. It's similar to reporting. Why don't you just push all your data into Datadog and you can do the most amazing reporting? And some customers like that. Others like everything to be inside Testkube. So we're supporting both use cases.
Okay, I'm going to come to
Who
the
had
back.
that question? I don't know. If, two more. Is that you? Okay. Oops. There you go.
Yeah, thank you. I was once a tester.
Okay.
So my question is more about concept, and especially in the world of AI. You have, let's say you have developed an agent and that is there to troubleshoot. Now, you were talking about continuous testing. If you are going to test now the agent, right, you're continuously testing.
The agent itself.
The agent itself,
Okay.
right, which is also doing its tests and troubleshooting. Where are you actually fixing things? I mean, how are you fixing the agent, for instance? So if there are bugs in, if you find bugs in the agent, then it's going to impact the entire testing, right?
It's going to have like a waterfall negative effect downstream. Yeah. So we do internally like eval testing on our own agents, and those are then tracked. So we have like relevancy accuracy metrics, right? And if they drop below some number, or those tests fail, and then someone has to go and fix. It's usually the prompt that has to be improved, or something is changed in the underlying model that we're using. It's a good question then. At that point, if we have to update the agent, and that update then has to go into our environment to make sure that the updated agent is actually being used. That's what you're asking, or is yeah.
Where are you going to update the agent, and then how is it you have to probably run the other test
with that updated agent? Well, so concretely, the eval test fails. Someone goes in and AI can actually help you once again troubleshoot maybe how the prompt could be improved to improve accuracy or relevancy in the answer. Then someone would have to go in and update the agent manually. I guess you could build an AI that updates the agent. It gets very meta, but we're not there yet. But I guess that's how it would work today. Someone would have to do this human in the loop there at this point.
Perhaps like a new problem, right?
Yeah, it is a new problem, definitely. So do you want a plushie for that? Okay.
How many plushies have you
That
left?
was the last. This is the last one. So. Oops.
Does anyone want to?
Sorry.
I'll donate my
hard
plushie back
throw.
to the audience.
So we should
if
do
you
like
want.
they are hard to throw. It's not just me, or I guess it's just
You
me.
want to? I'll donate this one back to the audience because we seem to have a lot of questions. Okay, we'll do one more. Okay, so what are the current limitations of kube tests? Can it work with services hosted on multiple clusters?
Sure. So there are very few limitations. No, so you can definitely work with services hosted on multiple clusters. The usual deployment is you have the control plane deployed in one cluster, and then you have these not AI agents, but runner agents that run the tests deployed in any cluster where you might want to run your tests. So those clusters could be anywhere geographically, physically, whatever, right? So they could be in different regions globally to run your tests. So let's say you're going back to load testing, one of our customers is using Testkube to orchestrate load tests to generate load from different places globally. So say I want to generate load from US East, from Asia, from Europe, et cetera, all against our application. And then they measure latency, et cetera, from all those different regions just to see how they behave differently. So I don't know if that answers your question, but it can definitely work with services hosted on multiple clusters, yes. And I'm sorry I don't have a plushie. Or actually,
no,
you
donated
yours.
this plushie,
Okay.
so
who asked that
that
question?
one?
Okay.
Okay.
Oops.
All right. I think we're going to call it there. So round of applause, please, for Ede. And that is it for us for tonight as well. So we're going to go on to the pub, which is called Friend at Home. No, Friend at Hand. Sorry, Friend at Hand. If you go out the door, go to the right. It's 3 minutes walk down the road. I will see you again on the first Wednesday of next month. Thank you so much for spending your evening with us. Take care. Thank you.